Okay, so now I'm going to talk a little bit about in this lecture about the three types of address translation that can take place. There's static NAT, and that's going to be very much like static IP addressing, a one-for-one assignment. Then there's going to be dynamic NAT, so you can take some addresses and map them into others, and next time around change them, that sort of thing. And the third type is going to be, the formal name is port address translation, sometimes called extended NAT. And this is basically where we add port numbers to the IP address. And it's a little like expanding the address space, but you do it on a very local level. So you're not really creating more IP addresses. You're just targeting a little better. You'll see when we walk through that and I take you through those diagrams. Okay, so let's get in. Okay, so this is where we left off. We had our terms, our inside network and outside network, and then the global addresses versus the inside addresses. So the global ones are the ones, how is an address in the outside network going to be known on the inside network? What address is an inside network address going to be known as on the outside network? So, an identity problem is what's going on there. So here's static addressing. And as you might guess, in static addressing, the NAT table, and so this, by the way, is something that's going to exist in the router. So there's a border router. That's one term you're going to want to be familiar with. Not too hard. It's sort of obvious. That's this guy, the border router. Everything else below that is going to be some local network or some network. There may be routers and other stuff here, but one of them is at the border. This is the one that maintains the tables, the addressing tables. And you can see from up above here, 192.168.10.10. This guy right here. Whoops, bad circling job, Bob. That server has been given an outside address of 200.226. So here it is. When viewed from the outside, this server looks like this address, 200.226. When viewed from the inside by his fellow network mates here on the inside network, he's known as 122.68.10.10. Okay? And these addresses are mapped one-to-one. All right? That's something you're going to want to see. One-to-one mapping of local and global addresses. So that means there has to be a global address for every local address. Here's this one, and there's that one. So I didn't really gain anything in terms of address space, right? I didn't gain much in address space. So this stuff, like any static addressing, is going to be configured by the network administrator, and it remains constant, just like static addressing does. Okay, so this is really just an address translation, static. You haven't gained any address space. You haven't leveraged any of that space. You might have gained some security, though, because you changed the identifiers of inside addresses. Okay, now let's look at the NATs. Same picture, but now we've got up here what we're going to call a pool of addresses. Right? 5 addresses. Here they are. That's the pool. Pool of 5 addresses. So those are given, and they're into the table here already. This side is right into the table. Okay? These are not port addresses. They're not an address of this port. They're addresses for messages. Okay? And they're available to be assigned, but they're not assigned one-for-one. Now here it looks a little silly. I've got a port of 5 addresses and only 3 items. 1, 2, 3. So there's not going to be any contention there, right? But if I have a larger inside network, which realistically is what I'm going to have here, for even to even be considering NAT, let alone dynamic NAT, to be considering dynamic NAT, you know, I'm going to want a global pool of addresses that's smaller than the total number of local addresses. Like we do at the DKI Tech Center. If we had NAT, I don't know that we do or don't, if we have NAT, it does not contain a pool of 128 addresses. Maybe it contains a pool of 5 or 10, I don't know. Something small. All right, so for dynamic address translation to take place, very simply, it's on a first come, first served basis. Okay? We can just say that. The pool of addresses, they're assigned first come, first serve. That's no big deal. That's obviously what you do. If 192.168.10.12 needs an address and none of these are used, the router is free to assign any one of them. And the most likely assignment is he's just going to assign them in order. Okay? I don't know that that's the rule, but that's what he's going to do. All right, so he just picks one from the pool. Now, as long as he doesn't get more than 5 requests simultaneously, he just needs to keep, you know, connecting and disconnecting, matching and unmatching a pool address with something over here. Maybe PC3 is going to go out like the packet is saying. Actually, that's the example that's given. Sorry. Maybe the server wants to talk, right? The server wants to talk now, and 1010 wants to go, and he just comes in here and does 192, 168, 10, 10, right? And anything coming from here is going to now get this new address right here. Right, so there just has to be here's kind of the rule. It's not the rule. You got to hope that there's enough public addresses. There's enough addresses on the global side for all simultaneous users on the local side. Okay, that's what's going to make dynamic addressing work smoothly and efficiently. But you can also see at the same time there's an opportunity for clogging here and waiting if there aren't enough global addresses to match the traffic. So this is the kind of thing that happens with certain time of day issues. There are certain times of day when the network getting on and off the island, for instance, the network traffic may overload the global address pool in some place or places where there's NAT at work. All right, now the third kind we call port address translation. As I said, it's also known as NAT overload, and you'll see kind of why in a minute. If the dynamic plan that we just talked about has too much traffic trying to get out at the same time and there's not enough addresses in the global pool, you're going to get overloaded. So this maps multiple private addresses to a single public address. Okay, so now that looks like something's going to clog up. You're going to have collisions. So the only way you can do this is if somehow you add some tag or tidbit that says, I got two private addresses and I only got one public address. I got 2 private addresses. I need a way to distinguish them. Okay? So if I only have a few addresses, it validates incoming packets. It validates that they were requested. Okay, so this is all going to be tied back to how are we going to assign multiple to a single. All right, we need some way to differentiate. So we're going to have collisions, double S, unless unless there's some added ID. And we do that by using port numbers. Now remember, port numbers are not part of the IP address. IP is layer 3 in the 7 layers. Port numbers are layer 4, right? They're used for, like, to differentiate UDP and TCP. They're used to differentiate file transfer protocols, trivial file transfer protocols, all kinds of special things. And if you remember, there is a whole lot of port numbers available. Many of them are assigned. Many of the port numbers are assigned, dedicated, and then there's thousands that are available for other uses. Okay, they can be purchased, leased, whatever. So port numbers are a way of, in my view, expanding the address, but only on a very special local place, okay, namely at the boundary. All right, now there's two types that I'm going to talk about here. The first type is called basic PAT, and the second type is called next available PAT. So I'm not going to pay attention to this figure a whole lot. I'm going to use the two, I wanted to call them videos, but they're not. But they're kind of step-throughs that are in your text. So I'm going to walk through those. They're as good as can be done. So the first one, which I called basic PAT process, is this in your text. And you can see there's the border router. Here's two inside network sources and two outside network locations. All 4 addresses are different, but these have 209.165 something, 2011 and 202.129, right? So those are good outside addresses. They're public addresses. These are private addresses, and they're both on the 192.168.10 network, 10 and 11. Okay, so that would be like in the DKI building, in our room, our classroom. Okay, now what happens here? This starts out, before we even get going, each source, 10 and 11, they come from the same internal network. Now, they're headed to different places. The bottom one here, 11, is going to the bottom one over here, 129. And the top one, 10, is going to 2011. Okay? Now, internally, they're going to have a port number, 1555. You see, and you might remember when we talked about ports in layer 4, we added this colon, and it was a way of extending the address as you go up into the higher levels of the network hierarchy. Okay, and this one is assigned 133. Okay, that's the ports they're operating from, maybe for the purpose they're using. Okay, so now they assign here's 80 is the same port number assigned to the destination, independent of the IP address, but taken as a collective, those are unique. Now here they go. They come along the internet, and what do? They get to the router. Okay? Now the router says, this is my source address. That's still a local address. This is my destination. That's a local address, but it also is the global address because there's no translation going on over there. Okay? And the next steps are, whoa, what happened there? The source addresses got changed to the global addresses. Right? The port numbers didn't change. This is still 133.1 and this is still 1555. But we changed the source addresses to an outside address, and oh, by the way, it's the same. 209.165.200.226, 209.165.200.226. But that's because that was the only global address available. It was the only inside global address available. So they both needed it. But we separate where the upper source was, we separate that from the lower source because of the port numbers. Notice the port numbers here, they got the same port number because they have different outside local addresses. Okay? So off they go now. Here's the tables that then get built up, and you can really see it for sure, but it's just what I described. The inside local address goes to an outside global address. The port number is constant, but here they had two unique IP addresses, which was what you'd expect on a local area network, but now they get the same outside IP address, the same global, they get the same global IP address. Okay? And now when they get over to the other side, they keep going and they separate because it's known where they're going. Okay, now let's see what the second alternative is, and maybe I can just pop this over like so. Here we've got something called next available port. So here you've got three addresses, it's still a pretty small network, and an outside network with a single line. Okay, so here we are, and let's just start this because you're going to see the obvious question. What if those inside network terminals, PC1, server, whatever, what if they have the same port number? The last one was easy because they had different port numbers. So, you can understand if I assign the same inside global address to them, you add on the port number, of course they're different. Let's see what happens now. Here they've got two different IP addresses. This is 12, right, and that's 11. The port number is 1444. Okay? So that goes to the outside address, 209.165.200.226, with that port number. So there's the table. Okay? Inside address 11. Hang on a second. I think I just noticed. This is interesting. There's actually an error. I'm not sure if it's the same in your text. This has the source address as 12, and yet if we go back here to the beginning, it came from 11. Okay, so don't get thrown off by that. There it gets fixed, and now they've got it right. 11 gets mapped to that same global address with the port. Okay? So that moves on and goes on to the outside source. So while it's over in the outside, number 12 actually comes forward with the same port number. But meanwhile, the original inside local IP address, hence the inside global address, is sitting over here in the outside network being worked on. It hasn't been answered. So in a way, you can think the outside network and the router have not released that inside global address with that port number. So let's now see what happens. So it gets along and it gets to the router, and the router got to be thinking, wait a minute, I cannot assign 209.165.200.226.1444. I can't do that again. I got somebody out there looking like that. So what does he do? He says, I'll call him 1445. So now, sitting out here in the internet are two packets, with two different global addresses, but the same global IP, but now with a different global port. Inside, it's still the same port. So this inside information and this careful mapping has to be memorized here in the R1 table. And in fact, that is what happens. Okay? So it's a way of extending or expanding the addresses because this poor router was only given one outside global IP address. So for his own purposes, he had to extend it by adding port numbers. Right? He added port numbers, so that differentiated them over here. So now when they come back, he'll know that 226.144 belongs to 10.11.144 and 200. So it's the use of port numbers. And notice these port numbers are big. So they're out of that group of special port numbers down in the 80s and the 87s and the 57s and 58s and things like that that have been pre-assigned. Okay? So that's it for the three types. I'm going to quit here with lecture 2, and when we return with 3, we'll move on to actually configuring this in the border router.